Oh, yes.
Where's Rachel? Where is she? Where'd you... Harvey? Where did you put her? Where did Harvey put Rachel? Hello. Hello. You're watching Nerdish. I lost my shoe. You gotta put your shoe back on. Very good. What are we doing here? Well, we do SAT, ACT prep for everyone. Yes, and the question is not where is Rachel, but when. 8 to 9:30 p.m. That's when Rachel is. Tuesday, Wednesday, and Thursday. Watch it. Just see what it's like. It's for free. All week long. You can ask us questions like where's Rachel and what you do with Rachel and where is Harvey Dent. They're both studying for the SAT. It's a very important test if you want to go to college or university. Nice. I should have said university first because it rhymes. Oh, that's Catwoman. That's okay. I think we know Catwoman because we're Batmen. Let's do a problem. Yeah. We did exponents last time. What should we do? Let's factor a quadratic. Okay. Man, when it comes to education, I'm an addict. Oh my god, but not that kind of addict. No, just a quadratic addict. I hope this is factorable. Oh, it's gonna be factorable. Add 6. Okay. 6 is for Rachel. Alright. Let's take out a 2. Let's make it equal to 0. That's a good idea. Okay. So let's factor out 2. X squared minus 2. How much time do we have before Rachel explodes? Ask Harvey. Harvey. Multiply to positive 3, add to negative 2. I don't think that's possible. Oh, shoot. That's okay. Sometimes you can't factor quadratics. And sometimes you can't save Rachel. I was about to say that. I'm so sorry. No, it's good. It shows that we're tight bonded. Like tight bond. Original wood glue. It has a tight bond. Like me and Levi.
Hi. It's me, Ring Matthews.
It's me also, Ring Matthews.
Today we're going to be Ring Matthews.
Yes. We're both Ring Matthews. Who are you?
Is that Brady and Levi? Oh.
Oh
no.
no.
I'm glad you decided to show up.
Our fellow viewer.
We were worried about you.
We were very worried.
We thought you weren't going to show.
You were worried by us.
I'll be Levi today. Hono, would you like to be Brady?
Yes, Hono. Say good.
Say that you'll do that.
Say it now.
Say that you'll be me.
Say it.
I've always wanted you to be me for a day.
Always felt that. I never knew how to put it into words, but now I do.
Yeah.
I want Hono to be bird today.
Yes.
That's what I want.
Oh. What do you mean? It's ACT, SAT prep. It's what it's always been.
What is that red dot?
Oh, we got Snort Dis Nesquik. That's a new one, right?
Snort Dis Nesquik.
Heyo.
Is there a red dot here, and why?
It's probably because there's something that's on.
I don't think so.
Here we go.
Right, that helps.
I didn't think that was gonna work. I'm really surprised. Anyway, Snort Dis Nesquik, how'd you hear about us? What do you want? We're doing ACT because there's an ACT this coming Saturday.
Did you snort an enormous amount of Nesquik and then realize, oh, there are probably 2 bozos streaming test prep on Twitch?
So the Nesquik somehow gave them that idea?
Yeah. I remember when I was very young, I told my sister to blow into the Nesquik bottle. The Nesquik
that
powder,
yellow
the
cylinder?
powder.
Yes.
It's definitely not a cylinder.
Well, it's got the curved sides.
Yeah.
So if you're able to go, nah!
It's a cylindrical prism.
Sure. It's a rectangular prism with rounded edges.
Sides. Has round sides.
The sides, there's two sides that are rounded, but the corners are the ones that are rounded.
Hi, I'm actually in a good mood today, by the way. I passed my probability test today with a nice 80.
That's because intersections and unions made so much sense last night.
Right.
Yeah. That's awesome, though, Hono. Good for you.
Hono, you don't deserve this good mood. You need to repress and dissociate from this positivity.
Yes, you gotta repress.
Otherwise,
you gotta dissociate.
You're vulnerable to being unhappy again.
Right.
And remember, you can't have unhappiness without joy, so kill them both.
Right.
Take them out to the barn and shoot them.
Right. What'll be better is just pure numbness.
Yes.
Yes.
Numbnity.
Detached from the world around you,
right.
so it can't hurt you.
Put all of your emotional baggage into alta ipsum, which we'll talk about later. You don't know what it is, but you'll see. You'll see. It's cool.
Yeah. You know, we teach SAT, ACT, but we also try to, give good life lessons.
Right. And maybe that's why nobody watches. Okay. So, let's talk about mathematics.
Yeah, does anybody have any questions to start?
What is math? Or, better yet, where is math?
Did we invent math, or did we discover math?
Right. And by we, we're talking about us two, specifically.
Yeah. What did Levi and I... What's our role in the whole math?
What's our deal?
What do we do all day?
Yeah.
We say we're tutors. Are we tutoring all day?
The answer is no.
Then the question becomes, then what are you doing all day?
The answer is Costco
Not
today.
Not much. I should have gone with Levi to Costco.
But you didn't because you had a child.
I had a child.
Yeah.
Yes, I had a sweet, sweet child. We worked on ACT.
Yeah.
And it was wonderful.
That's good.
Yeah.
I worked on ACT today, too. I like the SAT more.
I like the ACT more.
That's why we're such a good team.
Do you like olives?
No.
I don't like olives.
Yeah. But I like the fingers inside the olives. So, I like biting through the finger where the olive is, and then I spit out the olive.
So, wait, you're talking about putting an olive on your finger and then biting through so the finger comes off?
Yeah.
You like that? Is it always your finger or is it someone else's finger?
It's happened about 10 times where it's my finger.
Because you have all your fingers still.
Yeah. Well, they grow back.
Right. I forgot it because they're like hair.
They're similar to hair.
Yeah, so who's taking the ACT this weekend, huh? Who wants to talk?
Oh, good.
Who's got questions? We're going to talk about some circles, and we might get visited, I think, on schedule. We have a certain night coming in. Is that right?
Yes,
yeah,
we're traveling back in time.
That's right.
This is Hono's second favorite.
Yes. Well, since the chat's so populated with questions, I think it might be time.
Yeah,
so
why don't you set that up?
What else are we doing?
Etc. I think I wrote.
Oh, I like that.
Yeah. I don't know if you really do.
Maybe.
Let's go with a nice circle here. And we got a little center here. And do you guys all feel pretty comfortable at sectors, right? How do you feel about not sectors? Which is everything else. So you probably feel pretty neutral about everything else. I don't get finding angles in circles. Really? Okay. So let's find. So what's the formula again with the radian angle and the sector length or something?
S equals r theta.
S equals r theta.
Yep.
There you go. Polar's not on the SAT and ACT. It's only on Math 2, right? Bert?
Yes.
Got it. Think. Okay. That'll. Or that. Okay. Very good.
The ceremonial horn!
Get over here, Circumference.
Hello! I am Circumference, coming from the Third Crusade, in which we failed to capture Jerusalem. But we will try again, hopefully.
Many died.
Yes, except not me. Circumference. My goal is to marry the princess and then kill the king.
What's the princess's name, Bird?
Princess Diameter.
Yes.
The fairest princess in the land.
Yes.
I see you have a circle.
Yeah.
Very good.
Haven't gotten any farther.
I see you've got a nice middle, the little center point.
Yeah,
It's quite nice.
Not exactly centered in this circle, though.
Very good. Very good. So what brings you to my abode?
I have some problems that I need you to solve for me.
Absolutely.
Yes.
After all, I am circumference. Ha ha ha! I like how this is going. My forehead is looking a little large right now. I should probably readjust my chainmail hood. There we go.
Oh my god.
Oh, that's much better. It makes me impervious to arrows. Really striking a chord with this question. Ha ha ha! I was making all the fellow knights crack up on the Third Crusade. Circle question in the Discord.
Oh, Matthew. Where are you going?
I have to find the Discord. I guess we don't need this. You just put it on that.
Say something about sewing Discord somewhere.
Ah. Shall I?
Get out of here.
I don't know how to
Why don't you
use
do
that.
that while I pull it up?
Very good. What is the distance between center O and chord AB? I'll tell you one thing. It's shorter than the distance from where I started in Europe to Jerusalem on the Third Crusade, in which Christians failed to capture Jerusalem. All right. Distance between O and AB. Well, AB is a line. The shortest distance from a point to a line is the perpendicular distance. So this right here is the distance I want to know. Otherwise, this would be a further distance right here, and that's not how we usually describe the distance from a point to a line. How to find this distance? Interesting. Well, if you draw a radius to a chord, and it hits a right angle, it bisects the chord. You can draw this radius to other places on the chord, but if it's not intersecting at a right angle, it's not a bisector. But this is a bisector, so these two segments will be 4, half of 8. 4, 4. Now, the radius is 5. What to do with that? Here's something fun. You're allowed to draw lines on shapes as long as you obey the rules of geometry. Second rule that it's fun. The radius is any line you can draw from the center of a circle to any point on the circle itself. There's a radius here I think that might help. That's a radius, and I know that that radius is 5. So what is the blue distance? It's becoming quite clear, isn't it? I'm going to use Pythagorean theorem, but I know it's going to just be a 3, 4, 5 triangle at this point because I have a hypotenuse of 5 and a side length of 4, so this shall be 3. Have you a more difficult question, knave? 'Twas too simple. All right.
Oh, it's okay. So now we got to do Matthew's question.
Uh-oh.
What are you doing?
Is it here?
No, not that way. Here, let me.
The red.
Allow me, sir.
I'm scared. I don't know how to use such a newfangled contraption.
Should be that one.
When I was a boy, all we had was an abacus. I'm worried about the little red dot that I got rid of. What if that was...
Yeah, me too.
Yes.
Where did you put it? You just kind of dragged.
I just clicked on it. It just kind of went away. It's weird. It's doing something when you do that.
I don't think so.
Where is it? No, I mean like when you do that, look at this.
Yeah, no, it kind of does weird stuff.
Right.
I'm going to remove it and make a new one.
Are you sure you wish to remove?
Give us one moment.
Technical difficulties.
Oh.
That's... What is that? I wonder, do they see that?
Yes.
Ah. A brief glimpse of infinity. I had one of those in an opium den whilst on the Third Crusade.
Alright, Bird. Why don't you erase for me and I can do this one?
Very good.
Unless you want to do this one? I want to draw this one so I can draw on it.
Then I think you should draw it. Hard to make motions like this when you have muscles this big.
What are we looking for? T, I assume?
In the xy plane above, a circle is tangent to line T, the x-axis, and the y-axis. If the radius of the circle is 5, what is the value of T? Very good.
Okay.
We already did it, it's okay.
Very good. Okay. This one is hard.
Very good.
So we know that the circle is tangent to the x-axis, to the y-axis, and to this line 8, or this line that go, and this point of tangency here is 8 comma t, and we're looking for t. So when you get circle problems, what I like to do is I like to draw in radii to important points. So I'm going to do that. I don't know how much it's going to help, but I'm going to do it anyway.
Oh, it will help.
So this is 5, this is 5, and this is also 5. Now, we don't, this line is not necessarily at 45 degrees, so it's not like we know those angles or anything like that, because this is just t. So this is not necessarily 8 comma 8. It probably can't be, to be honest. It could, well,
we'll see.
We'll see. We'll see. So the only so there's nothing here I can really do visually, I'm pretty sure. We know that this is a right angle here. We know that this is 5 down here and 5 down here because you've gone 5 and you've gone 5. And so my guess is that we need to use the equation of a circle. That's the only thing that's really left to us, right?
It
might
be.
And that should work. Yeah, okay. So we tried to do it visually, and I don't think the radii help, aside from giving us the center of this circle, which is going to be 5 comma 5.
That's a help.
And that is a help. So now I'm going to write out the equation of this circle. We know the center is 5, 5. So I'm going to do x minus 5 squared plus y minus 5 squared equals 25, because this is the radius squared on that side. And now it's actually not bad, because this point is on this line, sure, but it's also 8 comma t. I think this question is made harder by having that. So my approach is to draw the radius to 8t, which is 10. Then it's 100 equals 64 plus x squared.
No, he said it doesn't go to the bottom left, so he lied.
Got it.
He lied. Well, here's something.
Oh, yes, yes, yes.
The slope of this line will be perpendicular to this line here.
Yeah, but we know nothing about that line.
Yes.
So I think
Wait.
this is...
We can figure out the slope, except we don't know t.
Yeah, I mean, this line could be anywhere. It really could be anywhere. It doesn't. We have no choice. I think we have to do this because we know this point, 8 comma t, is on the circle. So it has to satisfy this equation.
Well, hold on. Right, you're right.
Yeah.
So you're just going to find the y value.
So I'm just going to, yeah. So I
That's
think
it.
this line makes the question really confusing looking. If that line weren't there and you just had the point 8 comma t, you would say, oh, I need to find the y value given an x in this circle equation. That's all this is. Yes.
Correct.
That's it. So you just get 8 minus 5 squared plus y minus 5 squared equals 25. So we get 9 plus y minus 5 squared equals 25. Y minus 5 squared equals 16. Y minus 5 equals 4. And y equals 9.
My lord,
Yes.
technically there will be 2 points that have an x value of 8.
Yes, that's true. We would do positive and negative 4, and we get positive 9, and we get positive 1. But
of course,
it seems like that wouldn't be the case here.
absolutely.
What we just did is we found 8. So 8 is the x value, right? So that's the value here, which will intersect this circle at 2 points. But this one clearly isn't the one we want.
Of course.
We need the 8 something up here. It needs to be greater than 5 because it's clearly above that. And I don't think 1 was an answer choice. So this question is actually pretty straightforward, but that line makes you feel like you need to use it, and it gives you no information about that line whatsoever.
May I ask you a question, my lord?
Yes.
Do you think it's time for me to bulk or cut?
I think you should still be in your bulking phase.
Very good.
Yes.
Ah,
Or maybe cut makes you less of a target for arrows.
very true.
Yes.
Depends what I value more. My life or my abs? What's my life without my abs?
No life at all.
No life at all for circumference. For it is my abs which will help me attract the princess. And then I will kill the king after marrying the princess. I don't know if I've ever specified that.
Any more questions? That was a good question. I like it because it's scary, but it actually is, the math you actually have to do is very straightforward. And it goes back to the basics. The way one more. Nice. Well, I mean, ideally more than one more.
As in there's one more on Discord?
Oh, I see it.
What?
The dot. The red dot.
There it is.
There it is. I don't know.
I got it.
Don't get stuck.
Do you all see the red dot right here?
I don't think so. I think it's just an OBS.
There's a red dot. I'm getting kind of worried. We don't know what it means.
Yeah. You don't see it. Didn't think so. Cool.
Very good, Ring
Ooh,
Matthews.
This is fun looking and scary also.
Uh-oh. Uh-oh. What am I going to do? Hold on.
Alan.
Hold on.
It's going to be a whole mess.
About to happen?
What is about to happen?
Oh, jeez.
Oop.
Well done, Alan Perazaba. Well done. Ha ha!
Very good. So what would the name of that character be, Bird?
Do you think my parents are proud of me?
I think they're proud of you for other things.
Okay.
And I'm proud of you for that.
Good.
I like it when you do that. Significantly more than when you don't.
Okay, so if I want you to like me more, I should just do it more often.
Yes.
May I do this question, my lord?
Yes, you may, my lord.
Very good, my lord.
Um...
What a great system where we're both each other's lords. Pure equality right there.
Checks and balances, my lord.
Yes, my lord, of course. Balances and checks.
Yes, in that order.
Make it big, I can't read it.
It's very small.
Alan Perazba, we thank you very much for subscribing. It supports us as we continue to do this for free for not very many viewers, which is about to change very soon. Our plan is to make it explode.
Okay, so you start this problem. I'm going to draw for you.
In the figure above, triangle ABD, triangle ACE, and triangle BCF are equilateral triangles, and the ratio of AB to BC is 1 to 2. If the area of triangle ACE is 20, what is the area of triangle ABD? Well done, Levi. Well done. This will be exciting. What a fine picture, my boy. A fine, fine picture. All right. So all of these are equilateral triangles except for the right triangle in the middle. That's kind of fun. The ratio of AB to BC is 1 to 2. Why'd you stop?
Wait, is this one equilateral?
Yes. The only one that's not is the right triangle. Very good, Levi. Master Leeward, very good.
You know, it upsets me that I didn't do 3 for this one because that's the hypotenuse of the main one.
You didn't know. It's okay.
Right. There was no way for me to know.
So, the ratio of AB to BC is 1 to 2. We shall start with labeling that. Doubtful that the actual side lengths are 1 and 2. It's possible, but it generally is not the actual numbers in the ratio, because the ratio is simplified like you would with a fraction. So there's a workaround here. Instead of using 1 to 2 on the diagram, we will use 1x and 2x, because that is flexible enough to allow the ratio to still be 1 to 2, but to have those side lengths be as large as we need them to be. So this shall be x, and this shall be 2x. Now some things we can do with this. If that's 2x, this is also 2x, this is also 2x, this will be x, that will be x. We can also solve for our hypotenuse, at least in terms of x. So we have x squared plus 2x squared is equal to c squared, which shall be x squared plus 4x squared is equal to c squared, hence 5x squared is equal to c squared. Take the square roots of both sides, stop on your right foot, don't forget it. And we have c is equal to root 5 times x. So this will be root 5 times x, root 5 times x, root 5 times x. All right, the labeling is going swimmingly so far. If the area of triangle ACE, which is this one right here, is 20, what is the area of triangle ABD? Well, let us talk about equilateral triangles. The triangle ACE is area of 20. So, that's not steep enough. That's too steep. I can't really lean back because my head will fall off. All right. An equilateral triangle is composed of 3 60-degree angles. And the area of this is 20. So we have to figure out what the side length would be such that the area of the triangle would be 20. Let us call the side length S, S, and S. Great, we already know our S value. Our base, it's just S. But the height, my lord. This is the question. What will the height be? Law of sines? Absolutely not, Ring Matthews. The law of sines will only work if we have a side length for sure. We don't have any actual side lengths, so we're just going to use basic trig. You'll see. We have 2 right triangles. Both of them are 30, 60, 90 because this splits the top angle into 30. So using the ratios of 30, 60, 90, if anyone doesn't know those, please ask and we will talk about them. I know that the hypotenuse is s, therefore the side that's opposite 30 is s over 2, which I could have said before because it's half of this base. And then the height is going to be s root 3 over 2. So now we have ourselves a height in terms of s. The half base times height of this triangle will give us 20. And we have some values here. The base is s. The height is s root 3 over 2. And that is all equal to 20. I will multiply both sides by 2, giving us 40. And I will multiply these two terms to get s squared root 3 over 2. I will multiply both sides by 2 yet again, is equal to 80. I will divide by root 3, 80 over root 3. And now I will take the square root of both sides, giving us s is equal to the square root of 80 over the square root of 3. Any questions on how I got S? It's kind of funky. It's got a square root inside of a square root. Could have done some simplifying. We'll do it later. Don't worry. That's our S value. Now, AEC was the one that had 20 as the area. How do you know the side length? Isn't it in terms of x? We're coming back to that. What I did here is I just created an equilateral triangle with an area of 20 because I wanted to find what the side length would be. Now I know that the side length of this triangle is the square root of 80 over the square root of 13, so now I will return back to the diagram which has x in it. I was just modeling AEC. So now we know that the side length is this, but keep in mind that we originally had the side length in terms of this. Okay, very good, very good. So now we shall say that the square root of 5 times x, which is our side length here, is actually equal to that side length right there. The square root of 80 over the square root of 3. I want to solve this for x. It's a little messy right now, so I will square both sides, giving me 5x squared is equal to 80 over root 3 divide by 5. We get x squared is equal to, that would be 16. Yes, 16 over root 3. And we square root both sides, giving us 4 over, that would be, it's getting hot up here, the square root of 3, which is going to be 3, well, we'll just square root of the square root of 3. There. There's a way to simplify this, but don't worry about it. All right, so now the area of ABD. We finally know what x is. So we finally know what the side lengths of ADB are, which are 4 over the square root of 3. So let us return now to our equilateral triangle. I'm going to get rid of this part right here. I think that was a relatively simpler part of this problem because we need some space. So if we have a triangle, thank you for the follow. Circumference enjoys it. We have a triangle that is 4 over the square root of 3, and that is on all the sides. Our height by 30, 60, 90 is going to be, well, this will be half of that, so this little miniature part, it's hot in here, is going to be 2 over the square root of 3. Which means we're going to multiply that by the square root of 3 and divide it by, that's just it. We multiply this by the square root of 3 to get this. So our height is here. Our height is going to be the square root of 3 times 2 over the square root of 3. Okay, this is going to help us. 2 times 3 to the 1/2 over, this would be the square root of 3, which would be 3 to the 1/2 power to the 1/2 power, which would be 3 to the 1/4, which can be simplified. We'd subtract the exponents, leaving us with 2 times 1/2 minus 1/4 is 1/2. 2 times the square root of 3. Wow, that cleared things up a lot. Thank God for that. I thank you, God. The height is 2 root 3. So now we can actually find the area of this thing. The area is going to be 1/2. The base we knew was this. 4 over the square root of 3. And our height we just found, which is 2 root 3. Oh my gosh. So the 1/2 and the 2 will cancel each other out. So what we're left with, and I will put this up here, is 4 times the square root of 3 over the square root of 3, which again is 4 times 3 to the 1/2 over 3 to the 1/4. Subtract the exponents, and you get 4 times the square root of 3. It's that easy. It's that easy. It's that easy. It's always been that easy. Now, let me think of, hold on. ACE is 20. What is the area of ABD? That's 1 to 2. I think there was probably a much faster way, and we're going to look at that right now in case that's true. If this is true, then this will take us a minute rather than the 8 minutes we just did. Alan Parasba, I appreciate that you think it was beautiful. It's rather messy. Happens sometimes. Whew.
Beauty in the mess, my lord.
Of course it is. All these equilateral triangles. Okay. That's right. If you know that offhand, this will be a little bit faster. All these equilateral triangles are similar triangles because they all have 60-degree angles, and thus the ratios between their sides will hold for all of the sides. So if we're just comparing ACE, so this is ACE, which is 20. That's the area of ACE. And they're asking for the area of ABD. Let's look at the ratio of their side lengths. So ACE we said was √5 times x. And then ABD we said was just x. So the ratio of their side lengths was the square root of 5 to 1. However, if we then take that side length ratio and think about what that would do to the area ratio, the area ratio would be squared. This ratio is just for lengths, just for one-dimensional lengths. If you want to apply it to area ratios, you have to square it, which would give us 5 to 1. So if that's the case, this is 5 times bigger than this. That would make this have an area of 4, not 4√3. So now I'm a little worried. Levi, come up here.
Yes.
All right, this is so hot.
What's hot, my lord?
Oh.
What?
Hold on.
Okay. What's the question?
I want to walk this through with you.
Yes. Is it specifically how to find the area of an equilateral triangle?
No.
Oh.
It's not that. I think there's a much faster way, and I used it, and I got a slightly different answer than what I originally got.
Oh my gosh.
Yeah.
Wait, okay, so we know this, 1 to 2, so you have x, 2x, and rad 5x.
Yes. So we're comparing the area of this triangle to this triangle right here.
Okay.
This triangle has an area of 20.
You sure?
That's what they tell us. Triangle of ACE
Great.
is 20, okay?
Are you sure, though?
Shut up.
Okay. Yeah,
okay.
Got it.
So the ratio of the side lengths here is √5 to 1.
Yes.
Right? Because it's √5x to x.
Sure.
And if you're going to compare, if you know the ratio of side lengths, but then you want to ask what's the ratio of their areas, you have to square that ratio of side lengths.
Yes.
So that would make the ratio of their areas 5 to 1.
Yes.
So this would be 5 times bigger than that.
Yes.
And if that's true, if the bigger one is 20, the smaller one will be 4.
Yes.
Which is way faster. But then the question is, where did I go wrong here? And there's so many places I could have gone wrong.
Okay, what did you do?
Who posted this? Do you know the answer? Are there answers below?
Okay, I'm just gonna do.
Should we just erase this?
Well, okay, so the area of this
Is 20.
So you know that.
Yeah.
Um,
I mean, they've got the area of an equilateral triangle right there. S squared times the square root of 3 over 4.
S squared.
So let's get rid of this stuff.
Over 4.
All right, and
so S squared would be 5x squared, right?
Yes.
5x squared rad 3 over 4
Should give us 20.
equals 20, so that's 80. So divide by 5 is 16. So 16 equals x squared rad 3. Divide by rad 3, we get 16 rad 3 over 3 equals x squared. And then you take the square root of both sides. Ooh.
Right.
So 4 square root of rad 3 over 3 is...
You're going to get 3 to the 1/4 up top and 3 to the half on bottom.
Yeah, it's just over rad 3, so it should be times 3 to the negative 1/4 equals x, right?
Whoa.
Because this is you divide by rad 3, you take the square root of that.
Up top,
So,
isn't
yeah.
this 3 to the 1/4? And down here, 3 to 1/2. You're right. So it's going to be bigger on the bottom.
Yeah, so it should be negative. Well, I put it in the top. So this is what it is. So that's what x is. And you find the area of that in terms of x, right? So you just you plug this in to this equation, right?
Well, now
Or
we
no,
want to do over
no, no.
here.
Well, that's what x is, right? Yeah, so
Yes.
now we're finding the
Yes.
area with x. So that's going to be 16 times 3 to the 1/2, to the negative 1/2, rad 3 over 4. So this becomes
4.
4.
And those two are going to cancel
and
each other
those
out.
two cancel, which gives us
4.
what? Oh, 4. These
3 to the 1
these
half.
do cancel,
3 to the negative 1
or
half.
they add to 0.
Yeah.
So we just get 4.
All right, the answer is 4. So assume that if you have to do the amount of work that I was doing, there must be an easier way. And also I screwed up somewhere in there. It happens. This ratio thing is the way to do it.
Yeah.
Yeah. Oh, jeez.
It was fun, though.
That was a mess. And plus, it wasn't me that made the mistake. It was circumference.
Right. Can't let him have too much power.
Right.
He reminds me of Don Quixote.
Yeah, a little bit. He's kind of a bumbling fool.
Yeah.
Jeez, that was a mess.
I looked up how much chainmail costs. It's very expensive.
I'm sure it is.
It's like not cheap.
You know, I got it for $25 at a church rummage sale.
That's very cheap.
It was a steal. It was on a styrofoam head. I'll never forget it.
Did you get the head too, or no?
No. I mean, yes, I did. They had no use for a styrofoam head.
Yeah.
I made so much use out of that thing.
Yeah.
Yeah, I've used it for so many things. And when I brought it here from Chicago and I put it on my carry-on, I was stopped at security, and they're like, "What the hell is this?" And I was like, "Oh, it's chainmail. What are you talking about?" It's good for defense against arrows, knives, things of that nature.
And I feel like Professor X as well.
Oh yeah. Well, wouldn't you be? Isn't he the metal guy?
No,
That's
that's
Magneto.
Magneto.
Right.
Magneto uses one little noggin thing.
Oh yes.
Hey, Ring Matthews, do you have any more questions? These are so fun.
Those are tough questions.
Oh yes, we do have another question. Thank you, Ring Matthews. Are these just like the hardest geometry questions you can find?
We appreciate it.
We do.
Oh. No, but I think someone else had one.
Yo, someone else.
I'm taking a break.
Yeah, you are. You did great, Bird.
Ugh.
You're my favorite tutor.
Jacob.
Okay. Is this your question, Matthews? Whatever. Okay. So we have figure 2 over there. Great. And AE over DE equals 1/3. AE to DE is 1/3. I'm going to redraw this. Da, 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 da. A, B, E, C, D. Very good. Yes, it is. Okay. So 1 to 3. And then A, B, and C, D are parallel, so let's demonstrate that. And the area of ABE equals 6, ABE, so the area here equals 6. Great. What is the area of CDE? Whoa. All right. So tentatively, I'm going to label this as, AE to DE. Okay, that makes this problem doable. Okay, so X to 3X. Oh, so this is the same, pretty much the same problem as the last one, sort of. You have to use the same concepts. So, area of this guy is 6. I'm going to say that the area of this guy is 54. That's my guess without doing any actual checking of work. So, and I think I might be wrong. That angle equals that angle because we have two parallel lines cut by the transversal AD, so alternate interior angles are congruent. Alternate interior angles are congruent. We have angle, which tells us we have two similar triangles. We know that the ratio between the similar triangles, and also, it's not that this triangle, if you flip it over this axis here, is similar to this one, because we know that these angles are congruent and those angles are congruent. So it's actually triangle ABE
is similar to triangle A. So here DCE.
So that means that our ratios are a little, it's this side to this side. And that's important. So we know that our scale factor is 3 going from this one to this one, right? We multiply by 3, which means that our ratio, well, we're told basically our ratio is 1 to 3. So if our ratio is 1 to 3, ignore scale factor. Scale factor is not really something you need to worry about. But the ratio is 1 to 3 of the sides. So this is one-dimensional. One-dimensional. When you go to two-dimensional, which means you're finding area, you have to square it. You have to square this ratio. So now the ratio, that's it, equals 1 to 9. Because we have to square 1 to 3. So this is, I don't know why I'm doing it this way. This is not mathematical at all, but it's going to be 1/3 squared. Because it's, the ratio is 1/3 here and 1/3 here when you're finding the area. So now you have 1/9 when you multiply them together. Please let me know if that doesn't make sense. I can give you examples. If you went to the third dimension, if you had two cubes and the scale and the ratio of a side of one cube to the side of another cube is 1 to 3, and then you're finding the ratio between the volumes, it would be 1/27, because you have to do 1/3 times 1/3 times 1/3 for each of the dimensions, x, y, and z plane. Why do we square when it's two-dimensional? So let's do it with regard. This is about as basic as I can make it, I think. 1 yard by 1 yard. They had two triangles on June, said scale factor was 3, gave one side of 6, and asked the length of the corresponding side, which was 18. Yeah, that's fine. That's all one-dimensional. So, Alan, this is a yard by a yard. So this is 1 yard, 1 square yard, right? How many feet are in how many square feet are in 1 square yard? We know that 1 yard equals 1 foot, right? Well, no. 3 feet, right? 1 yard equals 3 feet. So if we draw our lines in here, so we have 3 feet now, 1, 2, 3, 1, 2, 3. Then we clearly have 9 square feet, right? 3 by 3. So when you're multiplying, you have to multiply your ratio as well. Whereas if you're finding the perimeter of these two triangles, the perimeter of this triangle in relation to the perimeter of this triangle is still the 1 to 3 ratio, because you're adding. So nothing actually changes. Here, when you multiply, you will have to square your ratio. Does this example here make sense with the 1 square yard equaling 9 square feet? Cool. So, because we have a ratio of 1 to 9 for the areas, we're going to do the area of A, so that's, or let's do 1 over 9 equals 6 over, let's call it A. So we can cross multiply. Actually, that works really well. A equals 54 units squared. Does this approach make sense? This is the same thing as last time. You have a ratio, and you're going up to area, so you square your ratio. If you went up to volume, you would cube your ratio. If you had the ratio of, let's say, 1 to 49 for areas, then your ratio of side lengths would be 1 to 7. So you go the other direction. Take the square root. Ta-da! Bum, 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 bum. Do we have any more questions? No. No more questions. We need more questions. For those of you who are here for the first time, I don't know who that would be, but if you want to ask your questions, you can put them in the chat. You can also put them in the Discord. Glad you get it, Alan. If you have more questions, ask them. If you don't, make some up. Make us feel like we're actually helping people. But ideally, you ask us questions that will actually help you. it that was lurking and then got a 36?
Daniel.
Daniel somebody. Okay. Oh, good. A list next week. That's actually not going to help you, Alan, because we're not streaming next week or the week after or the week after that. We're taking 3 weeks off starting after this Friday. So if you want, you can figure out those questions by Friday. I mean, you can also ask us in our Discord. We're totally happy to answer then as well. It's just that there's no SAT or ACT until June 13th, and this is when Bird and I go on vacation.
July 13th?
Sorry?
July 13th?
What'd I say?
June 13th.
Yeah, that's different, Bird.
Sorry.
It's okay. Good. Or if you can come up with something now, that would be cool too. It doesn't have to be math. It can be English or reading or science or whatever. Or, yeah, that's it. Or essay stuff. We can do essay stuff. I don't like doing essay stuff. Not as important. And it's annoying. Do we have anything in the Discord? No. No.
No.
8:50. Oh, I have to call his mom. Dang it. I have to call the mother of a child, Bird.
When?
This week at some point, but it's already more than halfway through the week now.
Oh,
Should have called yesterday. Okay. We can do more circle stuff.
Yay.
I liked that circle question. It was really hard though. We can do that UT question, Brady.
Which one is that?
Oh, you know what I want to do? That's what I want to do. How about math level 2? Yeah, if you can. Oh, what just happened?
Tell me tutor that.
We tutor math SAT 2, or math level 2. If it's something that's on the actual, the major SAT and ACT, then we'd prefer that you do that.
Tell him we'll do a free half-hour tutoring.
What?
We can do a free half-hour of math level 2 tutoring. We'll direct message him later.
Okay. We'll DM you about that, Matt. Let's do. Oh, this one's so fun.
Oh, miss, this one's so fun.
Oh, miss, you farted. What? Doesn't work? Okay, fine. Fine. No. Really? Where'd it go? Oh. Oh, what? Oh, okay, I see. Very good. All right. This one's hard, but I actually really like this question. So we're given these two sine functions. We have, and they give us a bunch of variables that make it very confusing. But just assume, you just have a, b, t, you have y, a, b, t, and it's just 1 and 2 for each of the separate equations. And they say which of the following statements is true about a1 and a2. So what do those variables do in this type of thing? Y equals a times sine of amplitude. Yes, a does amplitude. Brady, remind me again. It's sine of b and then x.
Parentheses x minus c.
B x minus c plus d, right? So a2 is less than a1. Yes, that is true. It seems like they have the same sinusoidal axis, or whatever it's called, the middle of the thing. I think it's called. Yeah.
Sinusoidal axis or midline?
Midline, that's the word I wanted.
Sinusoidal axis is what it's called though too.
Yeah.
That's all you.
Amplitude here. Okay, so that's the amplitude. So yes, we do have I'm going to say the A1 is, yeah, sure. A2 is less than A1. That's true because clearly the Y2 graph doesn't go as high up and down. What about relating them to 0 now? Where does 0 fit in to this? Is it bigger than them both? Is it less than them both? Is it in the middle? And how do you know? This is really cool. I like this one a lot. Well, obviously both are greater than 0. Hey guys, Robot Dancer. Hey guys, on the June SAT I kind of choked and didn't have time for 5 math questions. There was one question that I spent almost 5 to 10 minutes on. Should I skip questions that take too long? Yes, you should absolutely switch or skip questions that take too long. Also, did you run out of time on the open-ended ones, or did you run out of time on the multiple choice? Because you should be doing all of the open-ended ones first. They don't necessarily take any longer than the multiple choice, and you can't really guess on the open-ended ones. You can guess with a 25% chance of getting it right on the multiple choice.
He's absolutely right.
So, Ring Matthews, why is it so obvious that 0 is less than A1 and A2? How do you know for sure? Because they aren't flat lines. That's not what... Careful. You can have a negative value. What does a negative A value do? Be careful, Matthew. The amplitude, the magnitude of the yeah, there you go. The magnitude of the amplitude is what you care about for how up and down it goes. What does positive and negative do?
Correct.
Negative would flip, exactly. So, at 0 it would go down, exactly. So, what's your next step then? How do you relate A1 and or A2 to 0? I don't know what test this is from. Yeah, so this is it looks like the ACT, yeah. Because it has 5 answer choices. Y2 is negative, I think.
Y2 is a cosine graph, and cosines start up at +1. So these are both actually positive A values.
Yeah. So this is a hard problem. I like this problem a lot. All right, very good.
Sorry, I just wanted to make that noise.
Okay. Do you want to do the next one, Bird?
Sure, I'd like that. Ah.
No, that one's no fun.
Why? Hold on, I like that one.
You like that one?
I do. Yeah, Pythagorean Identity.
Okay, well this isn't going to be on it, is it?
Oh, Pythagorean Identity shows up on the ACT.
Yeah, this one specifically. Oh, you want on this side?
Sure. All right, for x such that x is between 0 and pi/2, the expression, that whole thing, is equivalent to what? So it probably looks insane, but there is an identity that if you know, everything is going to just fall into place. And the identity is called the Pythagorean Identity. And it states as follows. sine squared theta plus cosine squared theta is equal to 1. Two things. Number one, this little notation, the squared. Why is it put there? Well, here's what it means. If you have the value of sine theta and you square it, that's how we write it up here. Why don't we just write it, like this? Because it looks like you're taking the sine of theta squared. We don't want it to look like that. This is annoying with parentheses, so we place it there, okay? That's number one. Number two is why does this even work? And if it comes down to, if you draw yourself a unit circle and you block out an angle, we're going to call that theta. Unit circle is a radius of 1. So if you are familiar with your trig, you'll know that this side here will be sine theta, and this side here will be cosine theta. And this is a right triangle. So if you just apply Pythagorean theorem, you have cosine squared plus sine squared is equal to 1 squared, which is just 1. So we can rewrite it like this. Great. That's what we need to know, okay? Then the rest of this will make more sense, because you can solve for any one part of this in terms of the other pieces of it. So we'll start with the first thing. We have the square root of 1 minus cosine squared x, and that is over sine of x. So 1 minus cosine squared x. If you look up here, you can get this to look just like this by subtracting cosine squared to the other side. So if I were to do that, I would get sine squared theta is equal to 1 minus cosine squared theta. All right? So just like that, we can do a substitution. Where this is right here, we can place sine squared theta, which is, I'm sorry, everything's in terms of x. So it should be sine squared x and cosine squared x. So what this is going to turn into is simply sine squared of x over sine of x. If you take the square root of sine squared of x, you just get sine of x. So this turns into sine of x over sine of x, which gives you 1. All right? The second one, 1 minus sine squared will be cosine squared. It's going to be just the reverse of what we just did. So the second square root term here is going to end up also being 1. So in total we have 1 plus 1, which equals 2, which is h. Any questions on that? Oh, we got a nice little group of viewers here.
Yeah.
This is kind of fun.
Hey, for those of you who I'm going to turn this off. For those of you who are here for the first time, this is not you. Brady.
No, I'm just saying hi because you're here for the first time.
I thought you were saying you were here for the first time.
Well, I'm here now for the first time. Like, I've never been to this point in space and time.
Yeah. What? Yes. What? Okay. Ask your questions. People who are not, if you watch and just ask questions and don't ask questions, that's great. You're going to learn stuff. But for the people who are actively asking questions and sending us questions in the Discord, if you don't know what the Discord is, ask what it is. Or can someone link it in the chat real quick?
You could ask what the Discord is in our Discord.
Yeah. Don't do that, though. I feel like Ring Matthew's going to do that.
I hope not.
Yeah. Perfect time to talk about... No, it's fine. Thank you, Matt. So, Matthew...
Wait, Stream Elements?
Stream Elements, like, he does that, and then Stream Elements says it.
Oh. I was like, robots in disguise?
Yeah.
Keep going.
So ask questions, because Matthew asks a lot of questions, and he has learned a lot more than if he didn't ask questions. So you should ask questions.
Big time.
It's also very cool to ask questions.
Yeah.
Yeah.
You might think it's not cool, but they've run the numbers,
yes,
and it actually ends up being really, really cool. What could possibly be alta ipsum?
Well, we don't know. This is Accelerate.
Accelerate tutoring.com. Today, for you. Was today the end?
I think it's for you today. No, it is today for you.
Okay. Try it again.
It's what's for breakfast.
What?
No period.
Oh, except I see. It's what's for breakfast is what you said. Yeah. Accelerate tutoring.com.
Yeah. Okay. We'll do all this thing. It doesn't matter.
For you.
We're not sponsored by Tight Bond wood glue, but we used it to build the board. Actually, we didn't. There's no glue to hold up this board because then we can't take it apart.
Wait, didn't we use it for the supports?
Yes, we did use it for the supports.
So
we added that on.
We are sponsored.
We're not sponsored by
Tight Bond Original Wood Glue because Levi
Brady
and I have a tight bond.
You really should ask us your questions, otherwise we do this, which is totally
do you really
unhelpful.
want us to do that? We have wigs. We can just put on the wigs. Is that what you want?
Is that what you want?
Do you want us to just be trained circus monkeys for you? We'll do it. We'll probably enjoy it more than what we're doing currently. So it might even be a win-win. Don't let them do that. Hono.
Oh no.
Hono, do you want us to do the
Oh no, I feel like you should ask us questions.
Yeah, Hono, exactly. You got no leg to stand on there if you're just gonna not say anything. Do you want us to do the
Speaking of,
My
do you know
Master,
why?
Son the Great?
Do you know why flamingos stand on one leg?
Why?
Because if they picked it up, they'd fall on their butts.
Oh, all right, that makes a lot of sense.
It's also probably has to do with body heat retention.
Right.
But also they'd fall
It's
on their
mostly
butts.
because they would fall.
Yeah.
Yeah, that makes sense. Let me give you a good joke. What's a good joke? What's a good joke? Knock knock.
Who's there?
Boo.
Boo hoo.
Why are you sad?
Oh, very nice.
Knock knock.
Who's there?
Boo!
Boo hoo.
No. Like I was a ghost.
Oh. Nobody's there.
Yeah. I guess nobody's there. Brady, just do stand-up comedy for the remaining 30 minutes. Hey
You
man,
should.
I got a tight 5. I don't know if I have a tight 30. Never worked on that much material.
Oh god.
Oh jeez. What do I have? I'd have to go back to my notes. I haven't done stand-up in a while. One of them was just, does anybody know what's happening in South America? That was one of my jokes.
That's actually not that good anymore, because people kind of do now.
What's happening in South America?
Where's the question I wanted?
I have an SAT grammar book. I don't know if I should go through every chapter. It takes a while. Or focus on the concepts. I don't understand. Quicker?
No.
Porque no los dos.
Or focus on the concepts I don't understand.
Oh, or focus on the concepts. I don't understand. Quicker.
No.
You don't understand quicker than whom? Great question.
No,
Focus,
then who?
focus on the No.
Yeah.
Quicker than whom?
No.
Quicker than him.
No. That's wrong too.
I'm quicker than he?
Yes.
No one says that.
That's because they're wrong.
I am quicker than he.
Yep.
Ugh. Anyway, robot. Focus on the concepts you don't understand first, and then if you have time, maybe go through every chapter. But, I don't know. Focus on the concepts you don't understand and take some more SAT grammar sections. You want to identify those concepts that you don't understand. Is the answer to the joke the Venezuela inflation? Yeah, actually, Levi, that's what you were referring to.
Yeah.
Yeah, you know what? Never mind. In college, that wasn't happening, or at least not the severity that it's happening today.
Yeah, so once you get to college, it'll stop, is what Brady's saying.
Correct. Yeah, you're right. That joke is kind of gone.
Yep, it's coming on. Not
It
such a
killed.
type 5 anymore, huh?
It killed the one time I did it at Sigma Nu.
Nice, dude.
Yeah, dude, it was great. It was great. I had the whole room laughing. I mean, it was in the middle of it. I didn't start with that.
College versus university. University, generally the term is used for colleges that also have graduate programs.
Yes, and in the UK and a lot of places in Europe,
They actually call elementary school a university.
No, that's not true at all. They usually say I'm going to university when, they just don't really say college. Like
When they're going out to bars, they say I'm going to university.
Right, because that's the name of every bar.
Yes.
Yeah. I put a question.
Did you?
Yeah. I doubt it, Hono. Actually, that's good, because we were teasing Hono about not wanting us to get weird, so no wigs. Honeword. Honeword. Whoa.
Number 11?
Can
So
you mind if I sneak in this one?
I might.
So I want to finish up this union intersection thing with Honeword. Yeah, number 11. All right, Hono, let's take it home here. Let's take it home. Make it big, Levi. Make it big.
I'll make it big.
I want it to be big. Yay, it's big. Great. All right. On a given school day, which was a Tuesday actually, the probability that Nick oversleeps is 48%, and the probability he has a pop quiz is 25%. Assuming these two events are independent, what is the probability that Nick oversleeps and has a pop quiz on the same day? All right. So here is the deal. These two events do not influence each other, okay? Very good. So if two events are independent, all we do... Can you explain why sometimes the answer is sometimes, comma, however? Yes, Robot, there's a very good reason for that. It'll only take us like a minute to, or really 30 seconds to explain. We'll get to that in just a second. Actually, I can do it right now. Comma, however, comma is using however as a interrupting element, which means that it is not separating two sentences. You might be tempted to say, oh, however is a great transition, so it must be able to separate two independent clauses. It can't. Semicolon, however, can separate two independent clauses because a semicolon by itself separates two independent clauses. So it's like we're ending a sentence and just starting the next sentence with the word however, which is fine. However, I decided to take a bath anyway. That's a sentence. You can start a sentence with however. That's fine. Let me know if any part of that is confusing. All right, so if two events are independent, you just multiply the two probabilities together, okay? So we're going to have 48% times 25%. That's all this is really going to be. So 48% times 25%, which means we're taking 1/4 of 48%, which is going to give us 12%. Homeward, independent, you just multiply. Does that make sense? Are you happy with that? Are you at least content? I thought I had to divide. Divide what by what? The thing here is like, no idea. Okay, so here's what's going on in general. So, very simply, if we're talking about rolling a die, come on, right there, yes, rolling a die. It maybe has too much perspective, but whatever. All right, probability of rolling a 1 is 1/6. Any number you choose, probability is 1/6 because it's one option we want out of 6 equally likely options. All right, probability of rolling a 1 or a 3. With these or problems, where you can get one thing or another thing, but you can't get both, you simply add the probabilities together. This is going to be 1/6 plus 1/6 is equal to 1/3. Okay? So with or, that means add probabilities. All right? If we have two independent events, like saying 1 and then a 3, which means we're going to roll the die 2 times in a row. And they don't influence each other. They have nothing to do with each other. You know, you could get a 1, but then not a 3. Like the fact that you got a 1 the first time makes no difference on your probabilities of the second one, okay? So when you have these two independent events, I like to use and then. Typically they say just and, a 1 and 3. But this implies that there are two separate events, which is why I like it. You multiply. All right? So this is going to be 1/6 times 1/6 is equal to 1/36. Visually, why we do this is because if you think about what's going to happen on your first roll, you've got 6 options. 1, 2, 3, 4, 5, 6. What we want is just a 1. We'd like that. There are 6 options. That's one of them, 1/6. From each of those, there are going to be 6 possibilities that look just like the ones we just had. All right? They're all going to branch out into their own 1, 2, 3, 4, 5, and 6. All right? So what we're going to have is 36 branches here. 36 possible paths to walk down. And there's only one path that we're interested in, which is the one that starts with a 1 and ends with a 3. So that is 1 out of 36 total paths, which is going to be 1 over 36. All right, the chances at this juncture of getting a 1 is 1/6. The chances at this juncture of getting a 3 is 1/6. So we multiply them together, okay? That is generally what's happening here. They're independent. The fact that you oversleep has nothing to do with the chances of getting a pop quiz. All right? So it's just what are the chances of this happening and then this thing happening? And that is a very simple that's more simple than the things we were talking about last night. So we just multiplied the two probabilities together. 25% times 48%, which is going to give us 12%. I mean, one thing to keep in mind is that, like, it's less likely that he oversleeps, right? Well, so if it said nothing about its dependence, how would I know what to do? Great question. They have to tell you. They have to tell you. I mean, I think you could probably tell that these are independent just by looking at what the events actually are. The teacher that assigns the pop quiz has no idea that Nick oversleeps. So there can't be any connection there, unless you believe in the butterfly effect happening very quickly, and somehow him missing the bus triggers a chain reaction that changes the teacher's mind. But no, that's not what's happening here. So it's good that they told you it's independent. I would say it's a safe assumption that it's independent, because I never know how to explain when something's independence using math. Good question. Okay, the definition of independence. That is a good question.
Oh, mathematically?
Yeah. You got this?
Yeah, we've actually talked about it recently, I think. Independence would mean if something's independent of something else, that means that P of A equals P of A given B. Dang it.
Nice parenthesis.
So that means whether or not we have B, so coin toss is independent, yes, of the previous time. Exactly. So the probability of something happening, given nothing, versus the probability of that happening given something, given the other thing you're seeing if it's independent of, then if those are the same, then they are independent.
Yeah, Hona, this is more of an idea rather than something that you do the given part. So, like, the way that this applies to this problem is if the probability of Nick oversleeping being 48% would be the same probability of him oversleeping given that there will be a pop quiz, if there's no difference between those two probabilities, then they're totally independent. The fact that B happened does not make any impact on A. That's a little confusing. Guys, there was a question about sample size, which is pure concept. It asks which sample size creates a smaller margin of error. Choices are blah, 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 blah. I said put in sample size, there's more room for error. I put 100 because, okay, which sample size creates a smaller margin of error? Yeah, the more... Yeah, robot's answer, yeah, you get that. The more people you have in your sample, the less error you're going to encounter, the more accurate your results are going to be. Anyway, so Hono, this makes more sense because it seems like Nick oversleeping is the first event, and then the second event happening is the pop quiz. So, like, the probability of a pop quiz is 25%. The probability of a pop quiz, given that he overslept, is still 25%. It makes no difference that he overslept. Given B means, with thinking through that B happened, does the probability of A change at all? If one thing happening does not change the probability of the other thing happening, then the two events have to be independent. Hopefully that makes sense.
Someday we all die. Get it? Because I'm gonna die. I'm in one. That's what that was. I mean, it's true, but don't worry about it. Well, like, I've gotten just like numbers and events and told to tell if it's independent, so I don't get that part either. Wait, I'm not exactly sure what you're saying there. I've gotten and told to tell if it's independent, so I don't get that part either. What do you mean told to tell? Okay, yeah. See if you can find a question.
What time we at, leave?
9:20.
Very good. I love that time. It's a really solid time. Let it dry, let it dry, don't hold me back anymore. Let it dry, let it dry. That perfect wet is now dry.
All right, let's do a bit of. What was the other thing I wanted to do?
Alta Ipsum. Do you guys think you could list all the math concepts ideas tested on the SAT? Yes, I can say all of them right now in the next second, but it's not going to be very intelligible. If you slow it down and break apart all the sounds, all of them will be in there. You know, if you message us, PM us after this, we have a list we can send you. A list that we personally created by painstakingly going through a bunch of recent tests.
So this is a really hard question. Stop it, robot. It's mainly Brady, but we know this. This is a really hard question. You're probably not going to get anything this hard. So I'm going to do it unless somebody else gives me a question that they want me to actually do. But otherwise, I'm going to do this. So for every positive two-digit number x with tens digit t and units digit u, so that means we're going to have tu. That'll be the number. So if the number is 13, then t is 1 and u is 3. Yeah? Let y be the two-digit number formed by reverse. Okay, so this is x, and then y would be 31. Yeah, so we're flipping the order of the digits. And then they want us to tell them what is x minus y. What does that equal in terms of u and t? This is an extremely difficult problem. I did this a couple days ago for the first time, and it took me a couple. I figured out what the answer was by doing examples, but then I had to figure out how it actually happened and how to use. This is number theory stuff, and it's hard. You would never have to do this question in a way that you would have to use number theory this advanced, because they don't just teach it. But let's do some examples. So if x is 13 and y is 31, then x minus y in this case would be 13 minus 31, which would be negative 18, right? And how would we, and then which of these answers makes sense for that? We know that t is 1 and u is 3. So let's check f, 9t minus u. So 9 times t minus u would be, in this case, 9 times t, which is 1, minus 3. That would be negative 18. So that's good. Would the u minus t work? I don't think so. 9u minus t would be 9 times 3 minus 1. That does not equal negative 18. So we see that f is okay at the moment. We just did it. It worked for one example. That doesn't mean it's the right answer. But we know that g didn't work for this example, so we have a counter example, which means g is wrong. Then we have 9t minus u, so that would be, in this case, 9 times 1. Oh, it's just 9 times 1. 9 times 1 minus 3, so that equals 6, which clearly does not equal negative 18, which means that h is wrong. And then j, we have the same type of thing. We have 9 times 3 minus 1, and that's 26, which does not equal 18, or negative 18. So this is wrong. And x minus y is 0? No, it's clearly negative 18. So I guess 0 does not equal negative 18, which means that's wrong. Which means, oh wait, I already did, no, yeah, okay. So those four are wrong. The answer is going to be f. Now, we can do that with number theory in what I think is a really cool way. So you can't just do you can't do something like tu minus ut, because then what happens here, right? How do you end up with 9 times t minus u? That doesn't really compute this way. So this isn't exactly the way to do it. The thing here is these are just digits, right? T and u represent digits. So you can't put the t here and you can't put the u here because those are no longer digits. They're in the tens place now. So what you have to do, I think, is you have to say 10 times t plus u. That would be the first number, right? Because if t is your if t is your tens digit, you have to multiply it by 10 to get to the 1 of the 13. And then you have to add u, which just stays in this digit. And then you have to subtract 10 times u, because now the u is here. It's going to be the tens digit. So u is 3, but you need to get to 30 to do 31. So plus t. This is 13. This is 31. Those are actually the values in terms of u and t now. When you do the subtraction, you get 10t plus u minus 10u minus t. You combine like terms and you get 9t minus 9u, which when you factor out a 9 gives you 9 times t minus u. I like this problem a lot. I think it's really cool. You clearly can use... Oh, you sent the type of problem I was talking about in the third question down. It's not exactly what I'm thinking of, but I'm close. Okay, cool. If anybody has any questions on this, I think it's cool. I'm happy to talk about it. But notice that this really high-level algebraic stuff that has to do with number theory isn't necessary for this hard of a question. You can just find counterexamples. That is an approach that you should always take when you see some sort of fuzzy algebra question that only uses variables. Plug in your own numbers. But remember, just because something works doesn't mean it's right. It just means when it doesn't work, it's wrong. And then you have to use process of elimination. Okay, so Hono has a question. Let's see what that is, Hono. Third question down, you said? So this is the R being 15 to 19 years old, that part? Hey, Bert, I think there's another one for you.
Oh, yeah?
I think. Okay. Okay. Whew. Oh, boy. Is there more?
Yeah.
All
Just
right.
keeps going.
We're just going to ignore that. Maybe we don't need it. Or maybe we do.
Let me just read it first, then you can...
Sure.
Okay. A survey was taken of students' ages and what summer activity they preferred. There were 23 students in the age group 10 to 14. Do we have that total? Okay. That preferred to go to the beach. 15 students in the 15-19 preferred sports, and 45 students total preferred. Okay, wait a sec. 10 to 14 like to go to the beach, but it...
I think part of this, like that setup there, is just to...
There's
fill in
23.
the table.
Good. I was just making sure that Hono put that in there. 15 students in the 15 to 18 preferred sports. Okay, and length of work, blah, 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 blah. Okay, 150 students completed the two-way frequency table and answered the questions. All right, so assuming that you completed the table correctly, let's go through each of these questions. What is the probability that a student preferred playing sports given that they are 10 to 14 years old? So the given tells us only look at the 10 to 14-year-olds. That's it. We just kind of zoom in our vision to just 10 to 14-year-olds, of which there are 65. So of these 65 students, what's the probability that you preferred playing sports?
Hi, Michael.
And you got this right. You said 30 over 65. 30 over 65 is not 0.5. It's close to 0.5, but it's a little bit less. But maybe they're saying around the nearest tenth, and it's probably around 0.5. That's good. What is the probability what is the probability that student was 15 to 19 years old, given that they preferred working over the summer?
So the question is number 3. She wants the last one.
Oh, Michael Tarab. We haven't seen Michael Terab in a long time.
Yeah.
Hello, Michael Terab. Welcome. We're very excited to see you. Are being 15 to 19 years old and preferring to go to the beach independent events? Okay. I see what's going on.
Oh, thank my lord.
All right, well, given the definition of independence, let's talk about that. So the probability of A is equal to the probability of A given B. If this is true, we have independence, okay? So we have two different events, probability 15 years old and preferring to go to the beach. Those are two different probabilities. So let's first start with the probability of being 15 to 19 years old. So we're going to say that A represents 15 to 19 years old, or rather the probability of that, P of A, good. And B will represent the beach, going to the beach, which actually works really well because it's B. All right? If these things are equal, then they are truly independent, and if not, they're not. So what is the probability of being 15 to 19 years old? Of all the people here, there are a total of 85 15 to 19-year-olds out of a total of 150 kids in total here. So that would mean that that's 85 over 150. 85 over 150, okay? Now, this is kind of the harder part. The probability of being 15 to 19, given that you prefer going to the beach, okay? So in order to figure out this one, we have to first just look at who likes going to the beach, all right? How many kids like going to the beach? 67. So given that we're looking at that beach column only, what is the probability of being 15 to 19 if you're from that column? In which case, that is 44 over 67. Those two things are not equal. Therefore, these two things are not independent. Okay? Hono, what are your thoughts? Michael Terab, how are you doing? How's your year going? Got any fun plans for the summer? Oh, Levi, you got to see this.
Yeah?
Hono said that suddenly clicked so hard.
Really? That's pretty funny.
Yeah.
Are we done with this question?
Honeward, I'm glad. The clicking so hard, that's like an aha moment on steroids.
Yeah.
Chest bump,
That's
quick.
Oi!
Very good. What time is it? Is it 9:30?
It's 9:32.
9:32?
See?
Or 9:30 also? Which one?
9:32.
Like, also?
Similar, but not that.
Okay. I'm scared. All right. What's today? Today was Wednesday.
Yes.
We have
today
tomorrow.
continues to be Wednesday.
And we also have Friday cram session before the big ACT. And then we're taking 3 weeks off. Have we talked about Alta Ipsum?
No,
Let's
we
get
haven't.
it.
But real quick, before we do that, if you're here for the first time or not, please ask us questions. Go and study stuff. Figure out what you have trouble doing and understanding. Look, things you get wrong. Look at the explanations for them. If it doesn't work for you or you don't feel like you can do that type of problem again, we can talk about it on here. Just come with your questions. We can help you more then. We're not going to teach you step by step how to do the entire test because that service already exists for free. With Khan Academy is probably best in my opinion, although it's SAT, but it'll do ACT. And I really do hope that what I'm saying is really hitting home and clicking really hard because Brady is emoting it for you.
Alta Ipsum, it's our sponsor.
Yes.
It's an application you can get on your smartphone or on your computer.
Yep.
It lets you
Simultaneously.
set goals academically, track your grades, plan out your schedule, your study schedule. If you want to write an essay and you tell the app when it's due, it'll say, all right, tonight you spend an hour and a half writing the first draft. Thursday night, you edit it.
Yeah, and it won't only say that to you, but it'll write it down so you can look at it later.
Absolutely.
Yeah, and it will write your essay for you.
Well, after a couple of iterations, it should be able to do that.
Yes.
Right
Yeah.
now, it just
We're
comes
working
out
on it.
as wingdings.
Yep.
It's free for the first month,
Wingdings.
and it's pretty let's just say it makes things click so hard.
They click very hard once you have alta ipsum.
Yep. Levi and I have had alta ipsum for several years now.
Yep.
Before it was even developed, we had it.
Yep.
And I mean, look at us now.
Yeah.
If this is not the image of success, I don't know what is.
Yeah.
You know?
I mean, we're happy.
Oh, we're absolutely happy.
Very happy.
Yes, we're very happy.
We're in this black box and we can't escape, so
Yep.
nothing to do but be happy.
And we don't eat food, but that's okay because what we do eat is questions.
Right.
Which we get a good supply of.
Yes, your questions are our nutrients. And
Yes.
just like birds take in oxygen and spit out carbon dioxide,
Is that what birds do?
they spit it out.
Will
Right out.
Noidish write my essay for me? No, but alta ipsum will. Birds spit out carbon dioxide. It comes out
Yeah.
as spits.
Exactly.
Right.
Yes. And so much like that, Brady and I take in questions and spit out answers.
Quite interesting that you use birds when that's like animals in general.
I know. I started with birds and I realized true, but others also.
Right.
Yeah.
Right. But if you want to get technical, they need the oxygen for the process of respiration. In their
Cellular
cells.
respiration.
Right. But the actual energy, maybe I'm wrong here, but they get that from glucose. Right. Who you got for the NBA Finals?
Warriors.
I got one of these. That's what I got.
You got it, Bird.
All right, let's take it easy.
The Warriors are getting handled right now because they don't have 2 of their 4 best players.
I got my money on the winning team.
Yeah, you do.
Shall we?
Yes, have a good night. We'll be back here tomorrow and Friday.
Very good.
Both nights. So get ready for the AC.